With several tornado outbreaks in the last 2 weeks in the Deep South, severe weather season is in full swing. So it's a good time for an overview of what meteorologists look for to identify when thunderstorms have the best chance of becoming severe. Now, two characteristics often determine when conditions are ripe for thunderstorms to produce severe weather. They're known as CAPE and Shear. CAPE is short for convective available potential energy. It's related to the speed at which blobs of relatively warm and moist air in the belly of a thunderstorm accelerate upward. The greater that acceleration, the taller storms will build and the longer they'll last. Shear is short for vertical wind shear. It's a measure of how much the wind speed or wind direction changes as you go higher in the atmosphere. Typically, we look at the difference between the wind speed at the surface and about 3,000 feet up, and also the difference between the surface wind and the wind about 20,000 feet up. Generally, the greater these differences, the higher the risk for severe weather, because large shear allows thunderstorms to rotate, which can lead to tornadoes and the ability to support large hail. As an example, let's look at last Thursday in the Deep South. Here's a forecast of CAPE that afternoon. As you go from blue to green to yellow here, CAPE is increasing. Even the blue can support severe thunderstorms if there's enough shear, which I will overlay now. Now, this is between the surface and 20,000 feet. Anywhere shaded in purple is generally enough to produce severe thunderstorms as long as there's enough CAPE. But the most likely is within the darkest purple shading from East Texas across the area of high CAPE into the Ohio Valley. This time of year, upper air winds are still strong, so the area with adequate shear is pretty big, but it will shrink come summer and early fall. And now let me overlay the area that the Storm Prediction Center outlined for severe thunderstorms. Inside the yellow oval was a slight risk, the red oval moderate risk, the purple highest risk. Because it's not just about CAPE and shear, the risk areas don't exactly coincide with the overlap of the most CAPE and the most shear, but it's pretty darn close and shows that these two measures are very useful for locating where severe thunderstorms are most likely. You can infer both large CAPE and large shear in this visible loop from last Thursday. The explosions of textured clouds, especially in Alabama, indicate warm and moist parcels of air tapping into CAPE and rising quickly. Meanwhile, note the streets of clouds moving slowly north from the Gulf of Mexico into Alabama, indicating low-level southerly winds, while most other clouds are blowing quickly east from Mississippi into Alabama, indicating speedy high-altitude west winds, and thus a change in both wind speed and wind direction with height. If you'd like to look at the charts that I showed today, they're easy to find. Just Google Storm Prediction Center HREF, which stands for High Resolution Ensemble Forecast. Stay tuned. Our extended forecast is next.